Hello everyone, welcome to our course on Huawei Analytics Kit in HMS ecosystem. In the course of Analytics Kit is HMS Core 4.0. We have learned the capabilities and features of the kit and how to integrate the kit into your app to access its powerful and comprehensive data analysis functions. Today, we're going to talk about the cloud capabilities newly added for Analytics Kit in HMS Core 5.0 and how to integrate the iOS SDK. This course falls into two parts: Introduction to the Kit and the practice camp of how to integrate the iOS SDK. Now let's look at the service capabilities. Typical ones are cross-platform analysis, data export, and new analysis models and server APIs. First, let's come to the cross-platform analysis capability. Besides the Android SDK, Huawei Analytics Kit 5.0 now also provides the iOS SDK, so it is able to support one-stop, unified analysis for users across different platforms. With cross-platform analysis, you will be able to perform user-centered analysis and understand how your users behave on the two platforms. If you have more than one app type or app in your project, you can view the overall analysis report, or use filters to view the analysis report specific to a certain app type or app. You can even link users' activity data from different devices by using user ID to obtain cross-platform data views. Then, let's look at the data export capability. If you need to import the collected data to your own analytics platform or a third-party analytics platform for unified analysis, the data export function of Analytics Kit would be useful. You can do this in two ways. One is to create an export task on the Huawei Analytics page and download the exported data to the local PC. The other is to call the data export API of the Analytics Kit server to export data to your app server. We will give more details in the server API section. In Analytics Kit 5.0, some analysis models are added, including user lifecycle analysis, session analysis, industry analysis, and comparison analysis. Now, let's go into the details. Let's start with the user lifecycle model. The user lifecycle refers to the entire process from the time when a user starts using an app to the time when a user churns. It is generally divided into 5 phases: beginner, growing, mature, inactive, and lost. Not all users experience all these 5 phases. For example, some users may directly switch from the beginner phase to the churn phase. With the user lifecycle analysis model, you can perform routine data monitoring, insight analysis, and marketing decision-making to improve business operations of your app. Regarding routine data monitoring, the model provides the value and the trend of indicators, such as new users and users in different phases, for you to understand the operation status of your app. Regarding insight analysis, the model provides the composition and the mutual conversion trend of users in different phases, so you can explore high-value users and accelerate the conversion from new users or growing users to mature users. Regarding marketing decision-making, the model allows you to identify key users as audiences with just one click. Then you can perform multi-dimensional drill-down analysis based on different user attributes. You can also improve service operations through marketing activities such as message push. The model also provides the potential forecast and the churn forecast functions. It uses system algorithms to predict the conversion potentials and churn risks of users. You can then save potential users and risky users as audiences by one click for targeted analysis and operation. This is all for the user lifecycle model. Now let's move to the session analysis model. With session analysis, you will be able to learn the access path of users in your app, so that you can verify your operations strategies and carry out necessary product optimization. If the conversion path is clear, monitoring the conversion rate of each key step via funnel analysis would be sufficient. However, real-world conditions are usually more complex. A sheer number of paths can lead up to the final conversion. Hence, it is difficult to know for sure which specific conversion path has the shortest term and is most favored by users. Here are some challenges the path analysis model helps resolve. How does the user behave within the app between entry and exit? Does the user follow the path expected by the product manager? If so, which steps do users follow? Do user behavior path differ by region, phone model, or other characteristics? The path analysis model reviews the behavior path in each session in the form of a Sankey diagram. You can filter analysis objects by user attributes, audiences, and time periods. After you select an event, all paths corresponding to this event will be highlighted. This helps several relations between distinct behaviors which contribute to this path. In this way, you can draw the cause and effect, as well as the source of the bottlenecks. The model also allows you to save path as a funnel, and utilize the funnel analysis model to perform in-depth analysis and obtain insights into the causes of user churn. You will find these work easier than ever. For instance, you may find that the churn rate of new users is relatively high during the add to favorite, to submit order, or pay for order process. By conducting path analysis, you can save these events as a funnel and then position the cause of churn in the funnel analysis model to analyze the conversion effect. Analytics Kit also provides the industry analysis capability. The project overview page provides industry benchmark analysis for key operations indicators, such as the number of new users, number of active users, number of new users retained on the next day, and the number of the startup times. You can easily track their changes in timely manner. This helps you better identify the position of your app in this industry and understand the threats and opportunities it faces. In addition, industry analysis is also supported for new users, active users, startup times, and retention analysis. Note that whether to enable industry analysis is up to your decision. If you enable industry analysis for an app, the kit will calculate industry benchmarks based on app data by using related algorithms. Now, let's look at comparison analysis. This function supports new users, active users, startup times, retention analysis, and funnel analysis. It allows you to perform comparison analysis based on the app type, user attribute, and audience to identify key factors that affect business operations. For example, you can compare the activeness and the retention trend of user groups between different brands, models, and system versions. You can also compare the differences in conversion of funnel events among different user attributes and different audiences. Through multidimensional comparison analysis, you will better understand the position of your app in the industry and strengthen its competitive advantages so that you can keep ahead of competitors. That's all for comparison analysis. Now let's go to the use cases and the practices of the server APIs. Analytics Kit provides 7 server APIs. They are used to export personal data, query the export task status, delete personal data, query the deletion task status, create a data export task, receive the callback of the data export task status, and import custom user attributes. These APIs are mainly used in 4 use cases. Let's look at the first one. As required by the GDPR, you may need to allow end users to obtain an electronic copy of their personal data by providing a button in your app. When a user taps this button, your app server calls the User Data Export API to export the electronic copy of personal data that has been collected and reported to the Analytics Kit server. Your app server can also call the export task status query API to query the execution progress of the export task in Analytics Kit. Once the task is complete, the app server can download data within a specified period and provide the data for end users. Here is the sample code. Before calling the API, you first need to obtain the authentication token. This can be done by using HTTP2 class encapsulated in the getToken method to send a POST request to the token API and then convert the obtained token information into an authorization object for subsequent authentication. Now, let's check out the sample code for exporting personal data and querying the export task status. First, the data export API. We use the buildHeader method to construct the header of the HTTP request. The header contains 3 fields: authorization obtained in the previous step and the product ID and app ID of your app. After the header is constructed, we use the export user GDPR info method to send a POST request carrying the HTTP2 class to the data export API. If the status code 200 is returned, the API has been successfully called. The HTTP2 class has 3 parameters: API URL, user's AID in JSON format, and header used for authentication. Then let's see the export task status query API. We use the getExport task status method to query the status of the data export task. Expect the API URL. The other parameters are the same as those of the data export API. Note that the HTTP request for querying the export task status is of the GET type. The export status can be obtained by parsing the return result. Let's move on to the second use case. As required by the GDPR, you may need to allow end users to delete their personal data by providing a button on your app. When a user taps this button, your app server calls the data deletion API to delete all personal data that has been collected and reported to Analytics Kit server. Your app server can also call the deletion task status query API to query the execution progress of the deletion task in Analytics Kit. If the task is complete, the app server then notifies the end users of the deletion result in timely manner. The sample code is similar to that of the data export API. In the getDelete task status method, we call the buildHeader method to construct the HTTP request header required by authentication, construct the AID for deleting user data, and then send the POST request carrying HTTP2's class to the data deletion API. If the status code 200 is returned, the API has been successfully called. Similarly, the HTTP request for querying the deletion status is of the GET type. The AID follows the URL and does not need to be constructed in JSON format. The deletion status can be obtained by parsing the return result. Next, let's look at the third use case. If you need to import the data collected by Analytics Kit to your own analytics platform or a third-party analytics platform for analysis, you can use the Export Task Creation API to export the data collected by Analytics Kit. When the data export is completed, the Analytics Kit server will send a notification carrying the task execution status and the data download path to your app server. Therefore, your app server needs to provide an API to receive the notification so that the user can download the data in time. This code snippet demonstrates how to use the Apache open-source HTTP client library to send a request to the data export task creation API of Analytics Kit to create a data export task. In the request body, the start date, end date, and data export file format are mandatory, and the app version and operating system version are optional. If the status code 200 and the JSON response containing success are received, the data export task has been successfully created. Then you can view the created data export task on the Huawei Analytics page. The code snippet on the left shows the simple implementation of the Spring Boot used by the data export callback API. Imagine that you have implemented the HTTPS data export callback API that can be accessed from the public network. Then you can register it on the Huawei Analytics page. Analytics Kit will call the API when the data export task is complete, so as to push the data export link to you. Package the code in the preceding step and deploy it on the server. When the data export task is complete, Analytics Kit will send an HTTP post request to call the registered data export callback API. With the request body carrying the download link and export completion time, the download link has a validity period of 6 hours. Within the validity period, you can use the download link at any time to download the exported data file. Finally, we have come to the fourth use case. If your app server calculates some user attributes instead of obtaining them from the app, and if you want to apply these user attributes to the analysis reports provided by Analytics Kit, you can call the user attribute import API to synchronize the user attributes from the app server to Analytics Kit. The code snippet provides a simple example of calling the user attribute import API to import user attributes. The mandatory items in the request body are the data type, user ID, user attribute ID, and user attribute value. The data type must be set to 1 because the user attribute is customized. If the status code 200 and the JSON response containing success are received, the user attributes have been successfully imported. Some notes you need to know. You can report custom user attributes through the mobile SDK or synchronized attributes from the app server. However, a maximum of 25 custom user attributes are supported in total. If an attribute is both reported through the mobile SDK and synchronized from the app server, the attribute from the app server is used. Make sure that user personal data is not treated as custom user attributes for synchronization. Well, this is the end of the introduction to the new capabilities on the cloud and server APIs. Next, let's go to the practice camp.